And look, we have a Dapper here. Dapper, you want to
Hello.
say hi?
Happy Sunday morning for all of those of you for whom it is Sunday morning.
Yeah,
Like
I guess
me.
it is still Sunday morning for you.
Yeah. It's only
Um,
10:30 here.
oh yeah. That's I've been doing these at like about 10 Central. Um, and I 100% slept in today. My parents came over yesterday, and they and my husband and kind of me, nobody let me carry anything. Um, we emptied out our guest room and put a bunch of stuff into a storage unit so that now we have an empty room with which we can turn into a nursery.
Nice.
Um,
That's
so that
important.
was good. It was really cute. I was not allowed to carry. Dapper. I was like carrying like a heavy winter coat that like we don't need in Oklahoma, and someone was like, "Absolutely not. We're gonna carry. You can't. You're pregnant. You can't carry anything."
Yeah.
Like what
Certainly
is?
nothing over 10 grams.
Yeah, like what is happening? um,
I mean, it is definitely a good idea
yeah.
not to carry very heavy loads, although I feel like you probably would have been okay with a coat.
Yeah. So my family is being very sweet and protective. And I am a little beat. It was pretty hot. We were moving stuff. Um, I was permitted to at least walk back and forth with everyone and
Oh, they didn't
hold
break out the
doors.
wheelchair.
No, yeah. Not quite there. Um, uh, but that's good. And then let's see what else is going on. I'm going to be out of town next weekend, so I'm going to try to film a pseudoscience debunk thing to upload next weekend.
Nice.
Don't know if that will happen because if I haven't informed people, I'm just perpetually tired. But I'm going to try to make that happen.
Isn't that just adult human like
It's
constant
okay.
state of being?
Yes, that's an adult human constant state of being, but like as an adult human who is constantly doing 12,000 things at once,
Yeah.
being pregnant has made me be like, what is happening? Why can't I do 12,000 things?
Just turn that tired constantness up to 11.
Yeah, just dial it up to 11 and be perpetually uncomfortable too.
Yay.
Yeah, and I have this like hugely strong desire to like make things for the nursery. So I've made some pillows and embroidered them.
You're nesting.
I'm nesting really intensely. It's like I don't have a background up because my sewing machine is set up over here. I'm making so much stuff, it's not even funny.
Nice.
Anyway, and I'm out of town next weekend because we're going to visit my husband's family for like a little baby shower with them. Anywho, but then I'm not traveling anymore. So
verboten. It's too late in the pregnancy.
Can't do it. Too late in the pregnancy. In reality, it'd be safe to travel for a little while longer, but I'm also being a little paranoid.
Hey, look, it's better safe than sorry, right? Like, yeah, sure, it's probably okay for a little bit longer, but like, if you don't have to, just don't take the risk. It's fine.
Yeah, why take a risk you don't need to? Yeah. Yep. Oh, and thanks, Dora. Yeah. Thanks for the congratulations.
It's nice that I no longer have to like tiptoe around that.
Yeah. That's it's pretty. If I'm standing up, it's pretty unavoidably noticeable.
True. But yeah, for everyone out there, I knew a few months in advance, and it was like, don't tell anyone. I'm like, okay. And so every once in a while, I'm like, like almost gonna bring up, like, nope, gonna shut up. Just, shh. So
yeah.
So I want to say I'm mostly here because I want to know what stage of climate denial AIG is currently in. Because there's the stages where it's like, it's not happening.
Right.
It's happening, but it's not really a big deal, and humans aren't causing it. Then it's like, well, humans are causing it, but it's still not really a big deal. We don't really have to worry about it.
Right. And then there's the straight up, Jesus will come again and save us. This is a sign of the end times.
Yeah, that's like, you get that in certain religious groups that doesn't always filter into like the wider climate denial, because you still get a lot of people who are climate deniers who aren't like terribly religious or don't belong to religions that have like imminent apocalyptic prophecies.
Yeah.
So yeah, that's a somewhat unique strain that comes with a lot of Christian climate denialism.
Yeah, so this is ICR.
Oh, ICR.
This is ICR, not AIG. I think
Well,
I've done an AIG one before.
I don't know.
They all have a hot, really terrible takes.
But interestingly, often different and mutually contradictory takes
Yes.
on a lot of things. And it's one of the curious things to me about like young Earth creationist organizations. It's like, if you guys are so right and you have such great models and everything, you should agree a whole lot more on the basics.
Right.
Like, hey, which rocks were laid down by Noah's flood? Oh, you can't even agree on that? Yeah, makes it kind of hard to take a flood model seriously if it isn't a model.
Yeah. They're very bad at science. If anyone here watching doesn't think that.
No, they're not. They're not trying to do science.
That's true.
It's like telling someone, oh, you're really bad at cooking a pot roast. It's like, well, okay, but I mean, I'm making a salad, so.
Yeah, I guess in that sense, I am being very bad at making a pot roast because a salad is not a pot roast.
Right, and that's what they're doing. They're not doing science. They're making propaganda to keep people believing the things that they want them to believe. That's it.
Yeah. So before we get into articles, Dapper, what do you got going on with your channel? What's coming up?
Oh, goodness. Asking me is always a dangerous proposition because I usually have like a month or so planned out in advance.
Mm-hmm.
So let's see. 2 days from now is going to be Kent with Bent 80-something.
Great.
So that's Tuesday. That'll be at 6 p.m. Eastern, 9 p.m. Sorry, 6 p.m. Pacific, 9 p.m. Eastern. Then at noon Pacific, 3 p.m. Eastern on Thursday the 2nd, we're going to watch the final episode of The Jewish Matt Powell about Yosef Mizrahi, who has already... Oh.
I haven't caught up on those videos of yours yet, and I'm sad about that.
They're very dumb. I'll give you a spoiler warning for the second one. We find out that the Earth is a nice temperate star because it's off to the right of the Milky Way, whereas if it were in the Milky Way with the sun, it would be too hot.
What?
Yep. Don't even try. It doesn't make any sense at all. It's complete nonsense.
That's a lot of nonsense.
Yeah, the Earth is off to the right of the Milky Way, which is shaped like a banana, I guess.
Yeah, and that, my liege, is how we know the world is banana-shaped.
Right.
Best line from Monty Python and the Search for the Holy Grail. I didn't catch it until I'd watched that movie like 8 times.
On the 4th, I don't actually have a particular plan, but there's going to be something. There's a video I started reacting to on, I think, like a random Tuesday when a guest fell through and Bent couldn't make it. And I might like finish up on that on the 4th or something. But then on Wednesday, the 1st, Maddie.
Yeah.
You and I have a role-playing game on my off-topic channel, Top Hats Off, where you're going to be Claire Masters, our Blue Ranger. Smitty here is going to be Bonker, our Red Ranger. I'm going to be the GM. It's going to be a good time.
So fun.
TD Lane is probably not going to be there, but he does play our White Ranger.
He does. Bless his heart. He's in the middle of end of semester shenanigans. So
yeah, he's
busy.
Mm-hmm. But so we're gonna have a reason why his character is going to be absent for the majority of the time, and that will be plot relevant. And I think Bunker, the Red Ranger, will have to adapt to perhaps situations where not everything can be solved by hitting it.
Oh no!
Yeah.
That sounds like a hard life lesson for Bonker.
Well, he is literally a combat robot, so yeah.
Yeah. That's like, that doesn't make any sense. I reject the premise.
All problems can be solved by hitting them hard enough.
Is
his way of life right now. That might have to change.
Yeah. Okay. Awesome. I'm excited. Yeah. Okay. Should we get into this? We
absolutely should
for a while.
Yeah, I know. It's painful.
It's so painful.
I'm hoping it'll be less painful than Jack Chick trying to pretend that the Catholic Church created Islam, because I did that for the last couple of weeks on Saturdays, and my goodness.
That sounds terrible. Okay, I feel like there's supposed to be an image here that is not loading.
I mean, unless this is like a scan of a physical thing, is it?
No, this is their current website. This is Creation Meteorology, icr.org/Creation Meteorology.
It's good to know that meteorology is on the list of sciences you have to get wrong to be a young Earth creationist.
Yes. So, okay, so I think what this is going to do is like it links us to lots of different stuff.
Okay.
So, this is not okay. We're going to have to read this one because Arctic ice is my whole life. That's my whole PhD is Arctic ice. But let's read their opening statement.
Trees to the rescue. It's a little late for that, guys.
It's a little late. Meteorology is the study of atmospheric phenomena, including weather processes and climate trends. So that's kind of true. These days, there's effectively no distinction between meteorology and atmospheric science. But technically, meteorology would be the study of weather, and atmospheric science, like meteorology would be a subset of atmospheric science. And so meteorology by itself doesn't generally include climate, because meteorology is like what is going on today, tomorrow, like the next week, right? Those immediate, the goal of meteorology is generally to forecast what is going to be happening, like
short term. Yeah. This is stuff like, how's the week going to go? Not like,
exactly,
what policy should we enact for the next 100 years?
Yeah. So that's like, so if you think of atmospheric science as like the umbrella term, we have like meteorology and climate science both fall under that, but they're really looking at different timelines and different processes.
Okay.
But anyhow, through experiments, scientists gain a more complete understanding of what makes weather work. Sure. And a lot of math, just so you know. Through modeling, meteorologists can project the workings of weather to predict such things as storm tracks and intensities. I guess that's not wrong. Yeah. We also predict like what tomorrow's high is going to be. The same modeling technology is also used to extrapolate the workings of weather into the past. That's not strictly true.
Yeah, you need different longer term models to extrapolate climate into the past. And like, who cares about weather in the past? Like, does anyone care like whether it was sunny or not in some place on like July 2nd, 1232? Like, who cares?
Right. Like, so we don't do that. And we also, like, it's not just modeling, right? It's also taking paleoclimate data. So like, we're going to go gather actual observations.
But they don't think that exists.
Construct paleoclimate data sets. So, nobody had a thermometer on their phone in during the medieval warm period or the Little Ice Age, So no one in 1235 France was like taking temperature measurements every day, but we have a good sense of what the average temperature profile looked like for over the course of a year in 1235. Smitty has a good point. If it rained during a famous battle, that might be recorded, but doesn't really.
That's true. Yeah,
that's true. But yeah, so climate models and weather models are sort of concerned with two different things.
Yeah.
Generally, just so you know, a weather model only models the atmosphere, right? So it will feed in data from like how warm is the ocean, right? Or something like that. But the ocean is a static field. So the ocean is not also actively evolving inside of the model. We're just modeling the atmosphere. And so that is a pretty darn good thing to use for short-term processes. It's also much less computationally expensive. So you can reasonably run your hurricane model to update your forecast, right, in a time frame that's useful. Hey, Needed Atheist, thanks for joining.
Hello. Yeah, I guess it wouldn't be very useful if it's like, oh, the hurricane might hit in 3 days, but our updated model won't happen for 4 days. Like, well...
Yeah. Well, and a climate model takes months to years of, like, computer time, right? Yeah. So a climate model is going to have, you have an atmospheric model, you have an ocean model, you have an ice model, you have a land model, right? So you also have like a rivers model. So you have all of these separate models all running that get compiled and like that fed information between them every so often, right? There's a set sort of model time frame. Maybe it's every 6 hours, maybe it's every day, stuff like that. So they get compiled, and information from each of the models gets sent back out. They run for several more time steps, and then they talk, right?
Yep.
So that's what a climate model is doing. Is a climate model going to tell you, realistically, is it going to rain next Tuesday? No. A climate model is going to tell you, will the next 20 years be rainier than the last 20 years? Stuff like that.
Yeah.
And then we do use a tool called hindcasting, which is you use that for like atmospheric models to, hey, if we know the outcome, if we know that it rained, can we test our model to make sure it would forecast a rain event, right, for this particular day. But with climate models, you're going to sort of train the model on historical data, right? So we know this is what the weather did over these 50 years. Our model should probably capture the real life behavior, right? That's how we kind of know it's a good model or not.
I'm a little disappointed that hindcasting doesn't involve throwing deer, but that's okay.
Ooh, that is okay. Yeah. Okay. Excellent. Let's go back to reading this thing. I totally forgot to put my on-air sign on my door, and my husband is knocking on the door. It's fine.
Uh-oh.
Okay. So these standard models have been used, for example, to calculate intensity of huge storms that piled massive amounts of frozen precipitation on the continents, which initiated the post-flood ice age.
I'm going to need a citation on that one, guys.
I'm going to need a citation. Okay, sorry. I'm going to step away, and I'm going to put my on-air sign on my door so I'm not being very rude, and I'll be back in 2 seconds.
Okay. Well, while Maddie's gone, everybody, one thing I want to point out is like this thing where it says like, oh, trees. Here's the thing with trees, right? Trees do sequester carbon, but we can't really realistically plant enough trees to just counter climate change by planting trees. It's not an option. It's like still a good thing to plant trees. Trees are great for lots of reasons, but if you think you're going to sequester sufficient carbon to counter global emissions by humans, sorry, man, that math is just not going to work out. So I was just entertaining them while you were gone by saying things.
I appreciate that. Yeah, no, you can't plant. So trees are great. Trees, especially in urban areas, do things like lower crime rates, reduce urban heat islands. They have so many beneficial things. So yes, please plant trees, especially in urban areas. But that's not going to, that can help with like local air quality, but it's not gonna you cannot plant enough trees to put a dent in climate change.
Yeah. So, which I like that you pointed out all those great reasons to plant trees, because sometimes I feel like if I say something like, oh, that's not going to help with climate change, really, that means I don't want people to do it. I do want you to plant trees. I just don't want you to pretend that by doing so, you have solved climate change. You have not.
And so, okay, so these standard models have been used, for example, to calculate the intensity of huge storms that piled massive amounts of frozen precipitation onto continents. I think that's phrased in a really misleading way.
Well, yes, it's post-flood ice age, which isn't the thing.
Right. But doesn't, to me, so we'll like ignore this little last clause here, but this, to me, this is trying to suggest that, like, glaciers, right, and all of the ice, right, that we imagine, that we know was on, like, continents during the last ice age, which technically I guess we're still in an ice age, but that's fine. But if we're thinking, but what we think of as the last ice age, to me, that their phrasing makes it sound like all of that ice was laid down by like a few storms.
That's exactly what they think.
In a short period of time. Right? Like next year's, like 1 year's worth of storms just went nuts, and then everything was cold.
So the basic young Earth creationist idea behind the Ice Age is basically a few hundred years after the flood, an ice age occurs, which explains all of the glacial deposition that we see at like the end of through the Pleistocene, and it happened over the course of like decades, not tens of thousands or hundreds of thousands of years, decades. For fun, how many trees would have to be planted to solve climate change? Like 5 Earths worth. So I don't remember the exact numbers because it's been a while since I bothered to actually find them. But I remember it being at least in the tens of billions in terms of like orders of magnitude, and it might be more orders than that. It's like you're not going to do it, man. You would need everybody to plant multiple trees themselves and have all of them grow, and it's just not gonna happen.
Yeah, so I pulled that up because I wrote that down, and that should clearly be a video that I do, but I'm gonna have to do some back of the napkin calculations.
Yeah.
And Robert Madwell, makes a good point. You have to sequester the carbon, right? So you can sequester carbon in organic things, right? Mm-hmm. Like you could put it into a tree. That definitely takes it out of the atmosphere. Trees are made of carbon stuff.
Virtually all of the dry mass of wood is atmospheric carbon in origin.
Yeah. And then those trees are also like actively removing carbon out of the air. So that's great. But it would still take so much. But I'll try to do some back of the napkin stuff, and maybe that'll I'll try to make a short little video on that. Maybe that's what I'll throw up.
We'll cover the entire planet in redwood trees, and then in a few thousand years, everything will be fine.
Yeah, that's the other thing is like then. So if we stopped all carbon emissions today, how long would it take to remove? That's probably what I would set it up as. If we stopped emitting carbon today, right? We became carbon neutral today, and planted a ton of trees. How long would it take those trees? How many trees would we need to remove all of the carbon out of the atmosphere? Well, not all of the carbon, but get back to pre-industrial levels.
Right. Yeah, you do need some carbon in there. Otherwise, your crops are going to have trouble in a zero carbon dioxide atmosphere.
True. Yeah. Okay, so I'll fiddle with those numbers. It's a good question, though. Okay. So anyway, in reality, right, the reason we had an ice age was, so we have planet Earth undergoes periodic ice ages because of orbital mechanics, right? Our orbit is not a constant thing. It changes. These are called the Milankovitch cycles. I've got videos on all 3 of those up on my channel in the Climate Dynamics playlist. But basically, our orbit becomes more circular to more elliptical. Mm-hmm. The more elliptical it is, that's going to lead to like an ice age. The tilt of the Earth changes. The more that has more to do with like the severity of the difference between like winter and summer. But that, like, if you imagine a more severe tilt means your winter is going to be way more severe. And if that's happening at the same time that you're more elliptical, those are going to feed into each other to like.
Yeah. And once you get large scale ice coating, it also is increasing the albedo. So what light actually is received by Earth, much higher percentage of it gets radiated back immediately into space.
Exactly.
So you end up getting hotter, slower. It's sort of like if you've ever been on a hot day, the black top is much hotter than, say, a light colored concrete if you're just stepping on it barefoot. Or like you might have had like hot sand, but it's still not as hot as the sidewalk, which is mostly made of dark concrete.
Yep. So that's called the ice albedo effect. So the more ice you have, the planet gets cold, you make ice, that ice reflects more sunlight back, planet gets even colder, right? So it's a positive feedback loop.
Yeah.
Right now we're experiencing that in the opposite direction. So planet gets hot, ice melts, albedo goes down, so we absorb more of the incoming sunlight, so the planet gets hotter. That's why you see the Arctic is warming twice as fast as the rest of the planet.
I still say we paint the whole planet white.
I love it. It's a little more, or we plant a lot of white flowers literally everywhere.
Yeah, that could work too. Might be less dangerous in terms of like, not being toxic.
Yeah. So I think we're going to start with this: global warming halts, Arctic ice multiplies, because this is literally my field, my subfield, my super specific subfield.
Is this what you presented at that conference you were at not that long
ago? Something similar. Okay. So like broad topic of my dissertation, is how does a specific type of short-term sea ice loss event happen? So I look at how the atmosphere and sea ice in the Arctic interact as the Arctic is warming really fast. But I can tell you lots of things about Arctic ice. Okay.
Does it taste good in a gin and tonic?
No, because it's salty. It's frozen salt water.
So you're saying it would taste good in a martini?
A martini, yeah, or like tequila, or like a margarita. It would be great.
I feel like it's also probably full of like polar bear piss, so I'm not going to bother.
Yeah. Dig some up from the, like, get it from the bottom where it's actively.
Yeah.
There you go.
Okay.
All right. So this is an article from 2013, and this is by Brian Thomas, PhD, asterisk. That's concerning to me.
I feel like the asterisk is just going to be what the PhD is in.
Yeah. Oh, hey, look. This is his. Oh, okay. These are his articles. Okay, cool. What is your PhD in, Brian Thomas? Let's find out. Brian Thomas, ICR. Master's in biotechnology. Okay, and a PhD in paleobiochemistry.
That's oddly specific.
That is oddly specific. It also has nothing to do with, like.
Oh, he talks about dinosaurs. I might have to do a thing about this guy if he's doing dinosaur stuff.
Yeah, you might have to. So. Okay.
He's the author of Dinosaurs and the Bible.
Oh,
my goodness.
No. Okay.
Hey, fun fact, there are lots of dinosaurs in the Bible. They're just all birds.
Yeah, they're all birds. Okay, so, but I will say, understanding paleobiochemistry, which sounds actually super interesting, cool field, does not make one an expert in Arctic sea ice or weather patterns. I hate to break it to you, friend.
Yeah.
Okay, so Fox News recently reported Arctic sea ice is up 60%.
We've already got a problem.
2013.
Never start off your article with Fox News recently reported unless you're critiquing Fox News.
Exactly. Oh my goodness. Arctic sea ice up 60% in 2013, publishing dramatic before and after satellite images of Earth's Arctic region. I think I know what this is about. So let's go down. I hope they cite it. Okay. I'm hoping they show the picture here. So here's the Fox News article, and you're showing me, that looks like the summer, August of 2012 to August of 2013. Okay, Dapper, let me tell you what's going on here.
Okay, tell me.
Let me tell you what's going on. August of 2012 remains the record minimum sea ice extent for planet Earth, right, in modern times.
Okay.
So August of 2012 is super weird. So let me pull up NSI.
So I was actually going to guess, did they pick a year to compare to that was just an unusually hot year regardless? And yeah. The thing with climate is that there's a trend from year to year. Almost anything could happen one year to the next. The question is, okay, like, what's the moving average doing? Is it going up? Yes, it is. The fact that you can find little times in the middle, it's like if anyone was tracking like the COVID-19 cases, right? There were some good days followed by horrible days. The important thing is the overall long-term trend. That's why we take things like moving averages. In fact, if you look at climate like data that's trying to say, hey, look, the planet's warming, you usually find a moving average because it's important, because there's a lot of noise. Because, hey, Earth's complicated and kind of chaotic. That's the thing. The sun is complicated and chaotic too. Lots of things can conspire to make within an overall trend, one year be particularly warm above the trend and another year particularly low below the trend.
So, okay, so by the way, here is, can you see my graph?
I can.
Okay, so this is Arctic sea ice year to year. So this year, 2022, is here in the blue, right? Here we go. The dark gray line is what's called the climatological average. It's the average value from 1981 to 2010. So that's kind of what we consider normal.
Okay.
And then the shading around it shows you the interquartile range. So this from here to here, right, is
one quartile.
Like, yes, the interquartile. So like this, that's the middle 50% of the distribution.
Yeah.
And so, because normal in the climate sense isn't a line, it's a range.
Right.
And so, hey, look, here's 2012 in red, still is the record minimum. So let's take a look at what 2013 looked like. We can add that. So 2013 is in the orange line. So 2013 at its minimum extent, right, had significantly more ice than the previous year's minimum extent, but is still well below normal.
Yeah.
And then I'll just pull up 2021 so you guys can see. Yeah, so 2021, not even close.
Yeah.
And so I cannot even tell you how many papers have been written about the 2012 summer.
Yeah.
There was towards the end of the summer, in the middle of August, there was this huge cyclone called the Great Arctic Cyclone of 2012. I personally call her Gertrude because I feel like I feel like tropical cyclones are spoiled by getting names and Arctic cyclones don't get names, and that makes me sad. But no one else calls her Gertrude, just me. So she came in, and in late August, so we were already on track in 2012 to have a record low sea ice extent. The record before 2012 was actually 2007. So there's the 2007 curve.
Okay.
And if you notice, like up to this point in time here, right? 2012 and 2007 are really following each other, right?
Yeah.
And then it's just kind of all of a sudden 2012 ran away. And a lot of that has to do with, one, it was particularly warm early in the summer.
Okay.
And so the ice was thinning. And then this huge cyclone at the end of summer came out and just destroyed huge swaths of ice.
Right.
So 20, yeah.
I was gonna say, could I request the 2011 and the 2012 numbers be the ones that are up?
Sure. Let me take off 2013, 2021, 2022 is off.
Okay.
And we'll take 2007 off. So there's 2012 and there's 2011.
Okay. So one thing I want to point out is like, hey, look, it would be dishonest of someone to take 2012, 2011 and say, look how fast the sea ice is melting. It's all going to be gone in 20 years. And if someone had done that, ICR would have legitimately called them out and talked about how stupid and dishonest that is. You can't extrapolate a tiny little trend like that into, even 20 years from now, because, climate's years are too chaotic for that, right? There's ups and downs, and that's what they would have done. Mm-hmm. The fact that they're doing the exact same thing, it just sticks in my craw, because they're really quick to call out when people inappropriately give doom and gloom climate things, because that is a thing that happens, right? There are people who are like, we're all going to be dead in 2030, which, no, we're probably not. It's very unlikely.
Yeah. And so, by the way, so here's just 2011 compared to 2013. 2013 has more sea ice than 2011. And so there is interannual variability, right? Mm-hmm. From year to year. And that's, so by the way, the type of storm that led to this record minimum, that's what I study. That's what I study for my PhD. How and why did that happen?
I think I said AIG and not ICR because I'm just more used to saying it because,
that's okay.
Quite frankly, they're the better funded and more visible organization.
There you go. But yeah, exactly. So, like, the point here is that we're certainly on a declining trend.
Oh, yeah.
Because notice that all of these are below this climatological average of 81 to 2010, right? So if we're going to consider that normal, we're well below normal, even in 2013. Okay, so there's the fun graphs. Let me do, okay. So I'm not even going to read the Fox News article. I just wanted to make sure that they were talking about exactly what I thought they were talking about. Hey, we've gotten through a full sentence.
Yeah, and we've already found out that basically the entire premise of the article is misleading at best.
Mm-hmm. So how could ice increase if man-made industrial emissions, which have not appreciably diminished of late, continue to heat the Earth, melt glaciers, and kill polar bears?
Because that's not the only factor determining the current temperature anywhere in the world.
Exactly.
Because it's that simple.
Yeah, and notice here they mentioned melt glaciers. This ice we're talking about, these are not glaciers. This is sea ice. Sea ice and glaciers are very different. Glaciers are left over from the last ice age, and once they melt, they are gone. Sea ice has an annual cycle. The ocean in the Arctic freezes in the winter and melts in the summer. And so how was there an increase from one summer to the next? Well, in the 2012 to 2013 winter, the ice refroze, the sea ocean refroze until it reached its maximum in March and then started to melt. So cool. Scientists are producing conflicting predictions from the same available climate data. What pieces might their models be missing? I don't.
Okay, I hate that sentence because here's the thing, right? Every different model is going to give you a slightly different answer. Every single change to a starting condition using the same model is going to give you a slightly different answer. And technically, yes, they conflict. But none of them say that global warming isn't happening. None of them say that this warming trend is going to reverse without serious changes in emissions from humans. They don't disagree on the part that matters. They disagree on, like, okay, is the average temperature going to increase by like 0.1 or 0.2 or 0.1 or 0.15 degrees Celsius over the next set number of decades? And sure, technically that's conflicting models, but everyone agrees on the important part. It's getting hotter, and we know why. No one disagrees there who's actually doing real science.
So, like, for example, with Arctic sea ice, no one disagrees that we will have ice-free summers in the Arctic. That's sea ice-free summers in the Arctic by the end of this century, right? Yeah. That is a true thing. We would love to be able to predict that, sometime between now and 80 years from now, right? Is it going to be 20 years from now or 50 years from now, right? So it should be gone before 2100, but right now, like, it's not going to happen next year, probably not the year after, but it'll probably happen before 2100, right? Yeah. So that's where we differ. We know where we're heading, but we don't know how fast a path it'll take to get there. And I want to address a couple comments. So one, sorry, Robert adds that I missed this one earlier. Wind had a lot to do with 2012 low ice coverage, as you recall. You recall absolutely correctly. Those winds are coming from that big old cyclone. So that's generating lots and lots and lots and lots of surface winds that can have a myriad of effects on sea ice. So sometimes when people talk about that, they're like just talking about the wind. Sometimes they'll say cyclone, but like we're talking about the same thing. So the winds there are really important. Arctic scientists have a bad habit of not differentiating between winds and cyclones. And Robert Madwell, Whew, if I would drink for that if I was on Dapper's channel and was allowed to. So, but I'm gonna have a drink of water for that. Anyway, for those of you that know the drinking rules for Kent with Bent or the other Tuesday night adventures.
Yes. Yeah, saying things that more or less amount to AIG or Dix is definitely a drinking rule because they like to just copyright claim anything that uses any of their material, no matter how fair use it is. And the thing about YouTube's copyright system, and I understand that it probably has to be this way to cover their own asses legally, is that it heavily favors claimants versus those who are claiming hey, that's my copyright, versus people who are trying to use fair use, because all that you have to do is make the claim and YouTube automatically shuts down monetization and can even block it either regionally or globally. And you have to, as the content creator, take your own time to try to dispute this. And if the dispute goes in your favor, then eventually they'll put that back up. It's one of the reasons why I have videos that I upload usually more than a month in advance. It's because it can take up to a month for things like copyright claims to be cleared. And during that time, YouTube does not care about that video because it's not making them any money.
Yeah. So from Smitty, the 0th rule of the drinking game is don't be pregnant. On that note, I have already purchased 2 beautiful beers in like large bottles, right? In like the big
tall bottles, yeah.
Big tall bottles to have like day I get home from hospital from delivering. Both, one is a Belgian quad, one is a Belgian like saison, and just I had like the smallest sip of that Belgian saison recently. It's from a small brewery in Tennessee. I was recently in Tennessee visiting with some family on my husband's side, and there was like an amazing brewery there, and I was so mad I couldn't try any of the beers that I bought some to bring home.
Yeah.
Anyway, so I can't wait to do Matt with Maddie like after baby's born. I might have a baby strapped to my chest who is asleep, but
the baby can't play.
The baby can't play. The baby can't play, but I will be able to not suffer through Matt with Maddie sober anymore.
Yeah, does sound like kind of a nightmare.
That's how much I appreciate your friendship, Dapper, that I've been doing this with you sober.
Well, I mean, that means a lot because my goodness, I don't know if I could do it sober.
Luckily, male dinosaurs can't get pregnant, so you'll never have to find out.
Technically, neither can female dinosaurs.
Oh.
They become gravid, which is not technically the same thing.
Oh, okay. Fair. Okay. So, a technical comment published in Nature Climate Change shows that the actual warming trend from 1993 to 2012 was significantly slower than predictions from climate models. The authors also reported that Earth's global temperature warmed from 1998 to 2012 by between 0.05 and 0.08 degrees Celsius. During this time span, the overall trend actually stayed within the error margin. So there's been close to 0 temperature change in the last decade and a half. So let's talk about why a decade and a half is the wrong time span.
Yeah. Also, I want to say that this paragraph is very ambiguous.
Mm-hmm.
Like, for instance, are these predictions from climate models that assumed no action to mitigate climate change? Because one of the things is, it's sort of like the people who say, oh, I mean, look, not even that many people ended up dying from COVID-19. We didn't need the lockdowns. It's like, no, you idiot. The reason that it wasn't as bad as it could have been is because of the mitigation efforts.
Yeah.
You can't say that, look, this prediction about no mitigation efforts said it was going to be this bad. We took mitigation efforts and it wasn't so bad, so we should have never taken the efforts to mitigate the problem in the first place. And that's what a lot of climate denial types will do. They're like, oh, look, if you look back at like the 80s or whatever, they were saying it was going to be so bad by now, but it isn't. It's like, yeah, there's been actual concerted effort to try to lower climate, altering emissions. There have actually been like carbon taxes imposed, carbon limits, things like this. Now, is it enough to stop it? No, not even close. But you can't say that there hasn't been any action to mitigate it. So just pretending that we are now on a less bad trend than it would have been if we just taken no action like from the 1970s is kind of silly. And it happens a lot.
And when we're talking about global warming, right, the numbers that have scientists very concerned is the idea of warming by, say, a degree in 100 years.
Yeah.
Right? And so,
Tesla Ranger's like, well, we survived the Black Plague without vaccines. Yeah, some of us did.
Some of us did. A lot of folks did it. Yeah. Love this. And hey, as a reminder for all my folks in chat, I don't pick up on sarcasm like ever. So I need the /s to communicate things to me.
It's especially bad with text, yeah.
Yeah, it's even worse with text, but in real life. So when I was in the Navy, the guys in my office, they were actually, I found this really kind. And it was kind of funny too. When they were being sarcastic and I wasn't picking up on it, right? They would say something and then they would like tap their wedding ring or their class ring like on the desk to let me know they were being sarcastic. And I was like, oh, okay, now I understand. And so my husband does that now. And it's very useful. It's very useful to communicate that to me. So I just don't always get it. Anyway. Okay, so yeah, so this idea that they're looking at a 15-year period and so they're only looking at a 15-year period and it didn't grow as much in that specific 15-year period as I'm going to guess the average climate model was, means absolutely nothing. Right.
Yeah, that's what you call like statistical noise on the kind of timescales that you're talking about, right?
Yeah. So like probably what it says is we know there's a positive increase, right, in these years. In these years, there's a positive change. How much of that, right? So specifically, there's not a negative change. Temperature is not going down.
Mm-mm.
We know that. How much did it go up in these 15 years? That's not a question I'm even concerned with, you know, because one, a climatological average, we need at least 30 years to understand something that's normal, right? To get over what's called interdecadal variability. So our climate has other cycles that are going on. Like if we had several La Nina years in there, then that would act to mitigate global warming effects, right? But that doesn't change the overall trend of global warming. And so I say this like every time we talk about global warming. Remember that the average global temperature during the last ice age, when like all of North America almost was covered in solid ice, the average temperature difference between then and now is, no, between then and the start of the Industrial Revolution is 4 degrees Celsius, right? So in 60,000 years, we warmed by 4 degrees Celsius. And in the last 100, we've warmed by 1. So that is scary, comparing 1 to 100 versus 4 to 60,000.
Yeah. And one thing to remember is that 4 degrees over thousands of years did still cause significant extinction events.
Mm-hmm.
So that's apparently too fast for some organisms to adapt in terms of climate change. So that's
we don't have North American camels anymore.
No, or well, until they were reintroduced, horses.
Yeah,
which I guess is also true for camels. I mean, I have seen camels in North America.
Right, but not native.
And not wild either, or feral, right. I suppose I should say. They'd probably be feral rather than...
Yeah.
Because there's a fun thing. There are no wild horses in America. There are feral horses.
Ah.
Because the difference is that feral populations live in the wild but are descended from domesticated populations. So there are feral cats, feral dogs, and feral horses in North America, but there are not wild members of those species. There are wild wolves, which I guess you could call a wild dog, but whatever.
Yeah. Okay. So, so they're looking at such a short time span that it doesn't matter. And so but climate reports and predictions vary widely. Okay, so that is true. Because the biggest unknown in climate predictions, so climate model output, is how much are humans going to do to mitigate or worsen the effects of global warming and climate change. That is the biggest unknown. And so when you run a climate model for like the IPCC report, you'll run the same model several times. One, like, let's assume that humans do nothing and our CO2 emissions continue at the current like trend. What happens if we cut emissions in half? What happens if we stop emissions entirely, or we get down to pre-industrial levels tomorrow, right? What happens if we actually increase emissions? So that's the biggest unknown is human behavior. And so changing the amount of what CO2 emissions will be in the future is how you get these widely varying reports. And then also, if you're trying to ask a question that a climate model is not prepared to answer, like, will Seattle be more or less rainy? Right? Like, that's too small a question. Or like,
I'm gonna go ahead and say it's very hard for it to be more rainy, because having lived in the region,
yeah,
my goodness, I got there and it rained for about 2.5 months solid every single day, and I was just like, what is this? And I remember finding out that the green stuff on the sidewalk is just mold.
Just mold. Wow.
Just mold. It just grows on the sidewalk because the sidewalks are almost constantly wet.
Well, and that's because terrain effects.
So, oh yeah, there's a wind shadow there, or rain shadow. I mean, and that's on the rainy side of the rain shadow.
Yeah, exactly.
It's also why Spokane is basically a desert.
Yeah. Yeah. So like.
Which is also why when my grandmother found out I was moving to Washington, she was like, "Oh, it's so sunny there. I love it." And I was like, "Where did you go?" "Oh, Spokane." I'm like, "Yeah, okay, yeah. Sorry, Grandma. That's not my experience.
That's the wrong side of the mountain."
Yeah.
Yeah. Yeah. So like that's like going to be a really hard question to answer, because you'd have to look at changes in global wind patterns and evaporation rates out of the ocean at more northern latitudes, but we could talk about how will like precipitation, like annual precipitation change across broad regions, and maybe the border of that region is fuzzy, right? Because it's not going to be like, we know for sure it's going to be more rainy here and less rainy here, right? And so there's going to be this transition zone, and we're not quite sure what's going to be going on there, but we know this far south it's going to be less rainy, and this far north it's going to be more so, right? So you've got to understand what types of questions a climate model can answer.
Look, Manny, if you don't have firm, hard predictions with like meter scale accuracy that agrees with everyone else's predictions every time, I mean, really, can we say that the globe is warming at all?
Okay. Gosh. Okay, so the Intergovernmental Panel on Climate Change released their 2013 report. So their newer report came out last year, fingering man-made greenhouse gas emissions as the very likely causation agent to what, to them, has been a clear warming trend. There is a clear warming trend. There's no interpretation needed in that, and you do not need a climate model to show a clear warming trend. That you can show in observations.
Yeah, just the numbers coming in from weather stations. It's good enough.
Although they did acknowledge that the apparent halt in global warming over the last 15 years, they predicted that continued emissions of greenhouse gases will cause further warming. So let's break this down. It is not a halt in global warming, right? That is not over the last 15 years. This is not real life. Right?
Yeah, no, that's not what happened.
That is not what happened, even in their own data, right?
At
That's
best,
not
you
what
could
happened.
call it an extremely short-term slowdown in the rate of change. That's the most optimistic I could call it.
Yeah. And so again, I don't know for sure, but I think you did have several really strong La Nina years. Let's actually take a look. Let's do El Nino, La Nina. That cycle is collectively called the INSO thing. El Nino Southern Oscillation. So INSO data. Not. Hey, look, INSO data. Oh no, this is an AI thing. That's not what I want. I want El Nino Southern Oscillation from NOAA. Brilliant. And I don't know. Well, I'll explain that in a second. And so indicators, Southern Oscillation Index, access now. Okay. So blue should be positive numbers are El Nino events, negative numbers are La Nina events.
Yeah, I'm not surprised that they correlated blue with the masculine noun and a pinkish color with the feminine noun.
Yeah, and just eyeballing this, like I was thinking 97. Yeah, 97 had a really strong La Nina event, and then so did like 2005. We're getting real negative here, and they don't have corresponding El Nino events of the same magnitude, right? And so that's just off the top of my head of how we could have other atmospheric and ocean processes that are counteracting the global warming trend. That's not going to counteract forever, but will for a couple of years, right? It can be a mitigating effect.
I kind of think of it as like people say like, oh, water flows downhill, but you pointing out that at a rapid, it kind of goes a little bit up over a rock before continuing down doesn't really mean that water flows uphill overall. It means that, yes, in very small scales, in particular times and places, that trend does get reversed, but then it continues on. You haven't fixed the problem or said that there is no problem.
Right. And so INSO has like a 2 to 7 year cycle to flip from La Nina to El Nino and back again. And so if we're looking at such a short time span as 15 years, then those local shorter timescale effects are going to matter a lot more, which is why we take 30-year averages at a minimum to talk about climatological trends. Anyway, so, okay. Conversely, the non-governmental International Panel on Climate Change in IPCC. I've never heard of this one. I've only heard the Intergovernmental Panel on Climate Change.
Probably, and this is a supposition here. I might be wrong. I'm going to go ahead and guess it's because it's a bunch of anti-climate change or climate change denial like think tanks. And I use the word think tank in the broadest possible sense.
Okay. They released a 2013 brief arguing that since the warming trend essentially stopped in 1997 and greenhouse emissions like the 8% increase in atmospheric CO2 have not stopped, no close correlation exists between temperature variation over the past 150 years and human-related CO2 emissions. That's just BS. That's definitely BS. Because again, it's too short a time span, and any climate scientist worth their salt knows that. So the other thing is that the science of how CO2 affects global temperature is very, 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 very simple and can be measured in a lab, right? It is as simple as Okay, so the sunlight that makes it to the Earth, is coming in predominantly in a short wavelength. So it peaks in the visible range, but we're getting like these like high energy, high frequency, short wavelength energy coming in from the sun. Our atmosphere, things like CO2 and water vapor, and carbon monoxide and other greenhouse gases don't absorb at that wavelength, right? So all elements on all isotopes have specific wavelengths of electromagnetic radiation of light that they are able to absorb.
Yep.
And CO2 does not absorb the wavelengths that come in from sunlight.
If it did, then it would basically just make the atmosphere dark, visibly dark.
Mm-hmm. Exactly. So that sunlight comes in and it hits the Earth, and then the Earth absorbs this energy and re-emits it. But the Earth has different fundamentally different properties than the sun. And so when the Earth emits EM radiation, it's primarily emitting infrared, which is why the
fundamental difference is just being cooler, by the way.
Yeah, it's just colder.
Body radiation.
Yeah. And so CO2 and water vapor and carbon monoxide are super good and happy to absorb infrared radiation. So what these atmospheric gases do is they absorb radiation coming up from the Earth, and then they absorb that, and then they re-emit it equally in all directions. So half of that energy being emitted by the Earth gets sent back down to be reabsorbed and re-emitted by the Earth. So you get a trapping cycle of heat. You're trapping heat in the Earth's atmosphere. So if we do more CO2, then more of that infrared energy is absorbed. And again, we can measure the wavelengths that CO2 absorbs, right? And we can measure the Earth's output radiation. But you can do some very simple, like 1800s level.
Yeah, energy balance calculations are not that complicated, guys.
They are not. People did them by hand in the 1800s. Yep. Right. And so
I did them by hand in the 2000s.
Oh, hey, yeah, me too. So like this relationship is simple. So this no close correlation exists between temperature variations over the past 150 years and human-related CO2 emissions is complete BS. Also,
yeah, that's just a lie.
That's just a lie. And when we look at paleoclimate data, we see strong correlations between how much CO2 is in the atmosphere and how warm the planet is.
All right, Maddie, I just thought of something, though.
Yeah, what's up?
I think that during the flood, maybe carbon dioxide would cease to be a greenhouse gas because the flood models all produce so much heat that Earth's peak emission spectrum goes up into the visible.
Love that journey for you.
Just always had to mention the ridiculousness of the heat problems with all of their flood models, because it's like, yeah, you know, you're literally turning the Earth into Sun 2.0, right? That's what you're doing.
That's what you're trying to do. Okay, so this nonsense organization also contended that climate change trends seem to be more closely linked with solar activity, primarily sunspot behavior, a finding that Institute for Creation Research physicists have generally supported. Citation needed. That's not. Sunspot behavior can affect temperature, but not like. But that's not what we're seeing. That's not what we're seeing happen on planet Earth.
So, by the way, I looked up this NIPCC, and I'm just going to read a little bit from the Wikipedia, which, I mean, granted, you know, the Wikipedia, whatever, take it or leave it, go check out their sources is the real answer. Yeah. However, Wikipedia usually presents you with sort of the consensus in a field. Mm-hmm. So here's what they have to say about the Non-Governmental International Panel on Climate Change. So the NIPCC is a climate change denial advocacy organization set up by S. Fred Singer Science and Environmental Policy Project, later supported by the Heartland Institute lobbying group, in opposition to the assessment reports of Intergovernmental Panel on Climate Change. So they're set up to be an antagonist to the IPCC on issues of global warming.
That's not good science, right? By the team, the IPCC, the International Governmental Panel, or the Intergovernmental Panel on Climate Change, does not have an agenda of let's convince everyone that climate change is real, right? They have an agenda of let's report in as unbiased a manner as we can what current climate science says. If the data and the models and our observations said, hey, we did it, climate change isn't a thing anymore, that's what the IPCC report would say. But this organization is like, no, we're here to specifically promote that climate change can't be man-made. That's a terrible way. That's not science.
Also, like we read there, a large amount of their funding and control comes from the Heartland Institute, which not only rejects the scientific consensus on climate change, but also on the negative health impacts of smoking.
Oh, good.
Yeah. So we're talking about people who are like, cigarettes is fine. Don't worry about it. You totally won't get an increase of saying things like, I don't know, lung cancer or heart disease. No. Just puff away, man. Like, at that point, like, come on, guys. There's no reason to take this organization seriously.
There's no reason. Also, hey, look. This is the NIPCC says, however, the next few decades may be marked by global cooling rather than warming, according to the NIPCC report, which has not happened in this last decade.
No, it has not.
In which the secular scientists, I like that they're like specifically, hey, look, this isn't even coming from us. This is from the secular scientists say this. Also suggests continued warming would probably not have a long-term impact since Earth was much warmer millions of years ago.
Oh my goodness.
Oh goodness.
Yes, it is true that, say, if you went back to the Jurassic period climate, it probably wouldn't be the total extinction of life on Earth.
Yeah.
That doesn't mean it's a good idea for humans right now.
And again, the problem is the rate of change. Right?
Yeah, there is that too. And when I say it probably wouldn't be the extinction of life on Earth, I mean, yeah, ecosystems would recover over millions of years.
Yeah.
You know what? Humans have trouble concerning themselves over time spans like that. You should be worried about what's going to be up for your grandkids. That's usually about as far out as most humans can usually think. Because, I mean, let's face it, chances are most of us aren't going to meet very many of our great-grandkids. So think about, how is it going to be for your grandkids? And if the answer is, oh, this climate trend would be worse for my grandkids if it continued, and better if it was mitigated or reversed, then do that thing. And the fact is that, if we went to Mesozoic climate in the next 2,000 years, that's 4 million years away from that, things would probably be okay. All right, it's still going to suck for your grandkids, man, so don't do it.
Yeah. Okay. So, yes, the planet used to be warmer than it is now. Different things were alive then. And I think the other thing that people forget is when we're talking about the detrimental effects of climate change, Earth, the planet, is going to be fine. We are concerned about the things that live on Earth, the planet. Earth used to be molten. It did not care. Rocks didn't care.
The Earth is more or less a rock spinning through space. It will keep doing that regardless of how hot it is.
Yeah, Venus, right? Venus is a rock spinning through space. Venus is unbothered by the fact that its surface is basically molten. I don't want to live there.
That's a little bit of an exaggeration. It's well below the melting point of silica, which is the primary component of its surface.
Yes, but its crust usually lasts less than an hour.
No, it's less than a few million years.
No.
The crust of Venus? Okay, hold on. We're going to find out. Last Venus resurfacing. Let's see. So, according to NASA, the last catastrophic resurfacing event on Venus took place 500 million years ago, or a mega annum previously.
All right, I'll have to look into that.
Yeah, it's not quite that hot.
Fair.
It is hot enough to melt lead, which does have a fairly low melting point for metals, but like, yeah, you don't want to live there.
I don't want to live there.
There's a reason that the one liner that was sent there didn't last an hour. It's because it fried itself.
It got too hot for the electronics to work.
Yeah.
Okay. And stuff with the IPCC's predictions of continued warming, the New York Times wrote in 2012, some scientists think the Arctic Ocean would be largely free of summer sea ice as soon as 2020. But the August 2013 Arctic experienced record ice growth. I still don't like this ice growth phrase here.
Yeah, it's like we talked about it at first. It's deeply dishonest to take a really weird year, look at the next year, and then draw a trend based on those two data points while ignoring all the other ones. In the same way that if I had done the reverse, if I had said, look at how fast the ice is shrinking between 2012 and 2013, it's going to be gone in 2 years. That would also have been ridiculous and dishonest.
And that's what this sentence is saying. So one, this is why we don't like the New York Times is not a scientific journal. And so I'm sure there's like, if 2012 became the new normal, then it could have been true that we were sea ice free by 2020. 2012 was a very strange year, and I cannot express how many papers have been written about that year to try to understand what happened.
I'm glad to know it was weird for the planet as well as for me.
Yeah.
Like, okay, Earth, we're going through the same thing, buddy.
We're going through some stuff, man. And so, but what 2013 showed us was, okay, no, 2012 was more of an anomaly, right? It was 2012 is not really the new normal. It's still an anomaly. And so, like I said, no one disagrees that by the year 2100, we will have a sea ice free Arctic in the summer, right? But was it going to happen by 2020 or 2050 or 2080? That's what's hard to say. Because we don't understand a lot of these more short-term processes that 2012 highlighted for us. Okay. And this record ice growth, that's not how you should phrase that with sea ice, right? There was, it was not record ice growth. It's a normal amount of ice refroze. Right? We had a very average maximum sea ice extent in 2013. And if you want to compare ice growth, that's what you should be comparing. You should be comparing the winter maximum, because that's how much new sea ice you get every year. So yeah. Okay. Whatever the reason for these incongruous predictions, one thing appears certain: in believing that global processes lie either at the whim of man-made chemicals or were subject to imagined eras from some distant past.
Oh, I hate everything about this sentence.
Both groups fail to consider that the earth is the Lord's and
there
all
it
its
is.
Fullness.
Don't worry, Jesus is going to come back. It'll be fine.
We don't need to worry about caring for our environment at all, even though that's like tending the Garden of Eden, right? Tending the earth and caring for it was literally the first thing God had man do.
All right, this is for anyone who might watch this who is in the camp of, I think Jesus is coming back soon, so let's not worry about it. Christians have been thinking that for about 2,000 years now.
Yeah.
The previous ones were wrong. Maybe you're right. Maybe you are. But let's consider that you might be wrong, like the previous ones were, about the imminent timing of Jesus' return, and that you and your descendants might have to live on this planet for longer than you think. Because I know Jesus is probably going to be coming back in a couple years, probably, right? But just on the off chance, maybe play it safe. Just like, you're probably not going to get into a car accident today. Put your seatbelt on anyway.
Yeah. And a great thing to think about is like, of the play the game of what if I'm wrong, right? What if I'm wrong about global warming entirely versus what if a climate change denier is wrong, right? Or what if Jesus is coming back tomorrow, so it doesn't matter, right? What I am advocating for is clean air and clean water, right?
The horror,
right? So if we follow, and then what the deniers are advocating for is we do nothing, right? So what if I am wrong, right, but we still enact my policy propositions, what we get is clean air and clean water and more trees, more green spaces.
I think we should put up Robert Adsett's most recent comment because I really like it.
Yeah. Ooh, that's a really good one, Robert Adsett. I seem to remember a parable about the stewards left in charge of their master's wealth while he journeyed. That's a really good point. Yes.
Yeah.
We're leaving that up for a while.
Yeah. For those of you who might not be familiar with the story, it's a parable where Jesus is telling a story, right? So it's within the narrative of the Bible. It's supposed to be a fictional story.
Yeah.
So Jesus tells a story about there's a master, he goes away and he leaves some of his servants with some money. And some of them go and invest it, and one of them does some other thing with it, and then one of them just kind of buries it. Yeah. He's like, well, at least he'll still be here when he gets back. And the master comes back, and he's happy with the servants who have gone and made wise investments and grown what was left with them. But he's actually pretty angry with the other one, who's like, man, look, I gave you did nothing. Why did I even leave this money with you if you were just going to bury it? I could have buried it myself. What are you doing? And so the analogy here, to make it very obvious, is even from a Christian standpoint, humanity is left with the earth not to ruin, but to tend and care for.
Yeah. So let's do that.
Yeah, maybe. Yeah, instead of just, pumping as much carbon dioxide into the atmosphere as possible. Let's just not do that.
And so, even if you want to compare, we're thinking environmental policy, right? Do you want to go live in a highly polluted city in, say, China or India, right? No. But in the 70s, that's what San Francisco looked like. That's what New York looked like, right?
Oh yeah, I don't want to go anywhere near 70s LA or something.
Yeah. So environmental policy, again, gives you and me the benefit of cleaner air, clean water, clean air. And those are the immediate benefits. And the long-term benefits is the mitigation of climate change, right? Yeah. So
I like living in a place where my air quality alerts are from dust or pollen and not just straight up smog.
Yeah. Anyway, that's my rant on environmental policy. Okay. So this is nonsense. We can't just quote the Bible at the air and expect it to have less CO2. Okay. How can so many intelligent scientists with access to the same data came to such different conclusions?
Because some of them are lying.
And some of them are lying.
That's the whole thing, is some of them are just lying.
Perhaps their climate change prediction models rely more on what they wish to include rather than acknowledging that their best efforts are up against designs that transcend human understanding. That's not true. Also, we understand the atmosphere pretty darn well. Fluid dynamics are, listen, it's just the Navier-Stokes equation, right? And that's, I say just, right? In terms of PDEs, that's a beast, but we're pretty good at modeling that. Our forecast models for the 7 days have only increased over the last decades. Ooh, here we got it. James Duncan lived in LA during the late 60s, and we had this bad joke that we didn't believe there was air out there unless we could see it. Ooh, that's great. That's I once heard a quote about I think it was a novel, but it was set during the Dust Bowl here in Oklahoma Panhandle and then other parts of the Great Plains, more so other parts of the Great Plains. And it the character said something about at least we had milk to drink even if we did have to chew it, about how thick the dust was, right? By the way, environmental policies also will prevent future dust bowls. That was a full human man-made environmental disaster. So we know that humans can cause environmental disasters. We did it in the 30s. Anyway.
Yeah, that's another weird thing. Is it's like you don't have to go that far back in history to find human-caused climate disasters, and like, yeah, and in fact, that's not even the only one. Like, bad agricultural practices have caused climate disasters in other parts of the world in human history. Like, it's like we know it can happen, and sure, those were relatively small scale; they weren't global. But like the fact that you think that humans can't affect large-scale climate factors it's just demonstrably wrong. We know they have not that long ago. We're not even talking a full century ago here.
Also, I'm going to be a little angry. The verse that they quote, "The earth is the Lord's in all its fullness," that's from Psalms. That's from literally a poem. That is from parts of the Bible that even fundamentalists do not take literally.
Yeah. Wait, did they put an S at the end of Psalm? Okay, no, they didn't.
Did I
would have been I would have been angrier if they had.
I said Psalms.
Yeah, but you said it's from Psalms, which is accurate.
Oh, okay.
It's just sometimes people say like, "Oh, Psalms chapter 31." No, that's Psalm 31.
Psalm 31. Yeah. Okay. Ooh. Okay, so let's see what the other articles we've got. We've got warming and oil companies, global warming and hurricanes. How does real science analyze cause and effect? Rainforest fossils demonstrate dramatic climate change. Creation and climate science with Dr. Jake Herbert.
It's a nice picture that they have accompanying it.
Mm-hmm. Greenland ice-free not that long ago. Cool. And above it,
I kind of want to see fossils and climate change because that seems like a fun intersection of stuff that I spend time on and stuff that you study.
That's a good one to do while you're on here because I don't know. So it's by our same friend Brian Thomas. So he is a biology guy, paleobiochemistry, I think is what it said.
Which means we're slightly closer to his field here.
Yeah, paleobiochemistry. So, but still nothing. He has not formally studied atmospheric science or fossils, to my knowledge, based off of his credentials. Okay. All right. So.
Okay, so we're looking at a middle to late Paleocene formation here.
Okay.
That's just to orient us in terms of like when is this? So this is not that long after the end of the Cretaceous. We're in the earlier parts of the Cenozoic.
Okay, so researchers are discovering beautiful fossils from the. Can you pronounce that for me, please?
I mean, I believe it's Cerrejón. With a rolled R, so Cerrejón.
Formation of Colombia. One was a giant snake called the Titanoboa.
Yep. It should be italicized and it shouldn't have quotes, but whatever.
Most recently, a study examined the formation's fossilized flora, which looked the same as modern plants and the rainforest environment in which they lived. This research dovetails nicely with other studies on ancient Earth's turbulent climate. So can you I don't know enough about any of this stuff to know if what they're saying is nonsense or not.
So, as a rule, plants usually do have a significantly slower rate of like morphological change over time than animals. Okay. They tend to be more stable. So it is. I mean, to be honest, plants in the Cretaceous weren't that different from plants right now. The big difference would be like they didn't have much grass.
Okay.
But like if you were to look at like, the ginkgo trees, the pine trees, the redwood trees, the horsetails, the ferns, it all looks a lot like what you're seeing now, to the point that like there's a reason why when you're doing stuff like, the recent Apple Plus documentary was Prehistoric World. There you go.
Okay.
I think that's what it was called. They just filmed real plants because they're really close. So yeah, this paragraph it's basically correct. I mean, Like I said, take the quotes off of Titanoboa and put it in parentheses because that's a generic name and that's how you do genera. But that's a formatting problem. So I'm okay with this paragraph here.
Okay, so other people found some fossils.
Yeah,
cool.
I mean, Titanoboa is really cool. It's the largest known snake.
Ooh, that's cool.
Yeah.
There is evidence of dramatic ocean surface temperature changes as the global and local climate change, as well as global and local climate changes since the Cerrejón formation was deposited. For example, the researchers estimated the temperature back then by examining the numbers of large, smooth-edged fossil leaves. They suspect an average greater than 28 degrees Celsius, which is 82 degrees Fahrenheit.
So there is a correlation between how jagged plant leaves tend to be versus temperature, and it has to do with basically efficient photosynthesis versus problems with water loss. Because to do photosynthesis, you have to catch enough light, but then if you have your various pores in your leaves open too much during the day, you lose a lot more water. And so different shapes of leaves can catch different amounts of light versus giving off more excess water. So it's a balancing act. And high temperatures usually mean that you have more problems with water loss. And if I remember correctly, jagged edged leaves can help reduce that water loss at the cost of somewhat less efficient photosynthesis. So it's like with all life, right? Plants are always doing a balancing act. They need the sugar, but they also need that water. And if they give off too much of the water, then it doesn't matter how much sugar you make because you're dead anyway. And so it is the case that, one, there is significant climate change from the Paleocene all the way till now.
Yeah. So I'm looking up modern average temperature in Colombia. So so overall, it looks like it's between like 62 degrees Fahrenheit and 75 degrees Fahrenheit, mostly depending on altitude. And the average high temperatures remain during the hot season between 84.9 and 97. So depending on if they mean like the annual average or the average during the hottest season, right? This 82 currently falls within normal for the warm seasons. Anywho.
So one of the things is there's a thing called the Paleocene climate maximum. Which is the warmest it got in the Cenozoic.
Yeah.
And this isn't a controversial thing.
Yeah. That was the break between the Paleocene and the Eocene, right? Is when you get to that climate maximum.
If I remember correctly, going into the Eocene, you're getting up towards that maximum. Then in the Eocene, you're cooling off. And also, this is a time when things like, we have sea transgressions, which don't really continue through the rest of the Cenozoic. For most of the Cenozoic, the sea level has been lower. Why was it higher at this point? Because it was warmer.
Also, it's really pretty clearly been demonstrated that there was a large release of trapped carbon monoxide from the bottom of the ocean into the atmosphere that led to this huge temperature increase.
It's almost like carbon dioxide can be correlated with climate.
Almost.
Weird.
Okay. By comparing the temperature preferred by certain kinds of tiny sea creatures called foraminiferans. Foraminiferans,
yeah.
Foraminiferans, cool. In today's oceans with fossilized foraminiferans, geologists had earlier concluded that Earth's climate cooled from a period of extreme warmth in the early Eocene to the early Oligocene, when a large ice cap first appeared in Antarctica. Thus, major climate changes were occurring right when the Cerrejón formation formed. But
yeah, that's true. Over the course of tens of millions of years.
Tens of millions of years.
It's like, yes, there is literally no dispute that the climate has changed in the past. The problem is that we're talking about, climate change that's 3 or 4 orders of magnitude faster than it ever was. That's a little bit of a yikes zone right there.
Yeah. Also, I can dispute this paragraph, but there is no model in standard literature that can adequately account for the dramatic swings in ocean water temperature that led to these global climate changes. If the Earth has been subject to eons of slow and gradual processes, then where did the tremendous energy come from that apparently heated the entire Earth's oceans? If heat energy was added slowly, then sufficient time would have permitted the heat to dissipate. It is apparent that a dramatic and fast injection of heat occurred. Yes, so there was a dramatic and fast injection of carbon monoxide into the atmosphere that caused a huge and fast temperature increase. And then because that injection of carbon monoxide was a one-time event, right? Like it's we're thinking in like these long time periods, right? That happened sort of all at once, and then that reservoir of carbon monoxide was done with, right? Then it took a long time, but the Earth got back to its like homeostasis, right? So if we were to stop emitting, or if we were to reduce CO2 emissions to pre-industrial levels tomorrow and did nothing else, the Earth's oceans would eventually reabsorb all of the carbon from the atmosphere, right?
Well,
not all of the carbon.
Back down to normal levels.
Back down to like pre-industrial levels. Back down to what's, but that would take millions of years. At least, that would take a very long time, like tens of thousands to millions. I don't know exactly. I know it's like 2 orders of magnitude, but it's fine.
It's going to take longer than you're going to be around.
Yeah, longer than human lifetime. So the ocean is, in fact, very good at absorbing CO2 and keeping us in balance, right, in a nice homeostasis. But right now, and at this Paleocene-Eocene climate maximum, the amount of carbon being emitted into the atmosphere overwhelmed the natural system. And it took it a long time to reset.
I also want to point out, if the heat was added slowly, then sufficient time would have permitted the heat to dissipate. It's an energy balance problem. Once again, I don't understand how it is that, I guess I do because it's intentional, right?
Yeah.
This is a fundamental inability or refusal to understand very basic things about like just thermodynamics, right? If you add heat more quickly than you lose heat, even if it's by a very small amount, then over time, your system will warm up.
Yeah.
So if I spend 20 million years adding ever so slightly more heat from the sun than is emitted from the Earth, then that's going to be a 20 million year long warming trend. And if I spend 40 million years radiating ever so slightly more heat from the Earth than is absorbed from the sun, then that's a 40 million year cooling trend. And even though the amount per unit time that humans can interact with, like per day or something, is going to be minuscule, when I have 365 and a quarter days times 20 million, that can be pretty significant.
Yeah. Okay. A global flood, like that described in Genesis, would have involved rapid movement of crustal plates and catastrophic ruptures that released hot mantle material into Earth's oceans. This would have generated exactly the conditions required to form an ice age, very warm oceans, occluded skies, and cool polar continents. No!
Fun fact, guys, when you have ionized Earth's atmosphere and blown away the entire ocean as first steam and then, once again, ions, ice doesn't form. Ice requires it to be cool enough for this thing called chemistry to happen. This kind of thing, at a certain temperature, you can have things like biology and chemistry and physics and all that great stuff. Then when the temperature gets high enough, you can't really get biology anymore, but you can still get chemistry and physics. Then once the temperature gets really high, you can't get chemistry anymore, only physics, because chemistry is, interactions between atoms with electrons. But if all you have are ions, because all the electrons have been stripped off because of how hot everything is, you don't have chemistry anymore. that's the kind of heat we're talking about. Which, sure, I guess that's enough to get those plate tectonics going at race car speeds.
Yeah.
Yeah, that's great. But yeah, when it's so hot that at best the Earth is molten lava, and more realistically, it's probably just a ball of plasma. Yeah, that's not the kind of ideal conditions for an ice age.
Yeah, and like, okay, so also, this is the problem we're running into when we're saying like fast and slow. This heat energy is added fast, as in a few days.
Yeah.
Right? That's what the flood would say. The Paleocene, it's added over tens of thousands. Like, it's fast for geologic time spans.
Yeah, we're talking about a few million years.
Yeah.
And then many more millions of years are required to get to the point where we've actually reached the temperature maximum.
Yeah.
Because over that time, you're continuing to have that energy imbalance that lasts for about 20 million is, I think, about how long the warming trend ends up lasting. If I remember correctly, I might not double check on me, guys. This is, my off-the-cuff knowledge of the Cenozoic, which is not as good as my knowledge of the Mesozoic. So, But,
and also, yeah. I hate to break it to you, but during the last ice age, the oceans were not very warm.
No. But the thing is, if you truncate the entire Cenozoic down into like a few hundred years, then it's easier to pretend that it was, because, like they said, we have evidence of warm oceans from this formation.
Yeah.
And if that's post-flood, it can't be that far before the Ice Age.
Yeah.
Because you got to remember, they're trying to condense all of this into like 300 years or so total for all of this climate change.
No. That's insane.
And, yeah.
Yeah, like during the last ice age, oceans were cold. Oceans were colder than they are today, turns out. It's just that when you had precipitation fall on land, ice. Right, when you had precipitation fall on land in the northern regions, it froze and stayed there and didn't evaporate.
Yeah. Plus, if it were actually the case that the oceans were warmer during the ice age than they are now, you would expect glaciation not to reach the coasts as much as it reached continental interiors. But the problem is that that's not the case. We have evidence that sea ice was bigger, surprise, surprise, during the last glacial maximum than it is now, which means the water had to be colder, because to freeze water, it has to be cold. This is sort of a basic life fact that most people figure out by like the time they're like, I don't know, 3.
Yeah.
It's a fact that apparently is lost on ICR, that you can't freeze water if it's
above freezing.
Right. Like, what are you guys doing to me right now?
Yeah, you actually can't freeze seawater at 0 C either. It's got to be a little colder because of the salt.
But Maddie, it's just, the water was so cold, so warm that it froze. I don't see what the problem is with that sentence. There's no problems there.
The sequence of these ancient global events uncovered by scientific fossil sleuthing matches the events recorded in the Bible. No. Only the time scale differs. No. And removing the assumption of evolutionary time, it's not an assumption, it's a conclusion from the otherwise scientific reports.
Oh my goodness. Also fixes the problem of no evolution having occurred in... Oh my goodness. Okay.
Fixes the problem of no evolution having occurred in Columbian plants and animals since the Ice Age.
So here's a few things about Columbia. At the height of the last glacial maximum, Columbia wasn't glaciated. It was still a warm place with jungles. They were a bit cooler, but it was still a humid hothouse environment. This is one of the areas, like actually South America, like northern South America, as well as like the west coast of it, has been some of the most climatologically stable places on the planet that have ever existed in the history of the planet.
Yeah.
So by cherry picking one of the most stable continents in terms of climate that has ever existed and saying, oh, look, we don't see much evolution in the morphology of plants, it doesn't tell you anything. There's not a great reason for these plants to have undergone significant morphological change, because remember, significant morphological change usually comes about as a result of shifts to the plant's environment.
Mm-hmm.
And if there's not a whole lot of that, there's not a whole lot of reason for you to have significant morphological change. Now, what has happened is we've had turnovers in which plants are in what numbers, which is usually the result of smaller scale changes to climate, where while no particularly great solutions are to be found for morphological change is going to significantly impact the fitness of any given species, the relative fitness of different species will change. That happens. We can see that in things like when you take a look at like pollen fossils throughout things like lake vars or whatever. You can see that over time as the climate change, while you might not have complete turnover in the flora, you get different prominence in different kinds of flora. You can see that with just simple things like, do we get more like evergreen trees or more deciduous trees? Because they have distinct pollen.
Yeah.
And yeah, it's just everything about this is both wrong and cherry-picked. And I hate the degree to which that's the case.
Yeah, so just, team, it turns out the closer you are to the equator, the more stable your climate is.
Mm-hmm.
Fun fact.
I think the oldest desert in the world is in South America. I think it's the Atacama Desert.
Oh yeah,
it's like it's in Chile, and it's at least 3 million years old as a desert, which is very unusual. The Sahara is not even 1 million years old. The Gobi might be older because I think that Gobi's been arid for like several tens of millions of years. But yeah, like this is a very stable area overall, and like. When we talk about Titanoboa, Titanoboa was living with things like Purosaurus and Carbonemys, and basically the age of reptiles, so-called, just never ended there because the climate didn't really change there. So there wasn't a whole bunch of these weird mammals that find it easier to get along after the climate change because there really wasn't any. So sure, the dinosaurs disappeared, but then the snakes and turtles and alligators, caimans, but they're in the alligator family. So they took over.
Yeah. Okay. Do you have anything else to say on this article?
I just hate it.
I hate it so much. I'm done with it. I've moved on spiritually and emotionally.
It was fun though to think about Titanoboa. I do like Titanoboa.
Titanoboa is very cool.
Yeah. And as Smitty says, Titanoboa is dope and caimans are dope.
Both are dope. Agreed.
Dope. Yes.
Okay.
Especially the spectacled caiman.
Yeah.
Because it looks like it has spectacles. Because it's not just bears that have spectacles in South America.
Excellent. We're referencing my character for our Power Rangers TTRPG, whose animal is the spectacled bear, and who I, Maddie, am now obsessed with.
They are really cool.
Because they're so cool.
They're also the only surviving members of their subfamily, Tremarctinae.
Yep, and Claire Masters knows that, but Maddie doesn't. Okay, so I think let's go ahead and wrap it up. We went through 2 articles. We've been going almost 2 hours.
True.
So thank you so much to everybody that joined us for this live stream. You guys are the best. Love hanging out with you guys. Like I said, next weekend I won't be able to do a live, but I will try to have a pseudoscience thing up. Shoot, I don't know what it's gonna cover. It might be how many trees would it take to solve climate change? Don't know. I want to find out now. But
too many.
But I don't know. I might pick my new favorite. Like I really liked doing that video on alkaline water because I was like, this is very dumb.
I remember at one point Dr. Oz was telling people to drink lemon juice to help get their blood to be more alkaline, and I was like, Are you kidding me? Even if you could change your blood alkalinity by eating things, lemons, one of the most acidic foods that exists, isn't going to be the thing that does it for you.
I learned that lemons have a pH of like 2.
That's really low.
Isn't it really low? Also,
that's like Coca-Cola levels low.
If you look at like foods that are promoted by the woo-woo folks as alkaline foods, literally all of them are slightly acidic.
Yep. They're alkaline in the sense of not being as acidic as possible, but not in the sense of actually being, alkaline. Right?
Yeah.
Just go chew on some lime. That'll help.
Yeah, that'll help.
Don't actually do that though. You'll get some pretty bad chemical burns if you just chew on. Oh no, I'm thinking lye, and I said lime. Either way.
Yeah. Limes are fine, especially in rum.
No, I mean lime, like the rock.
I know.
Oh.
You gotta come up with your Vol'dran's grand plan with some limestone to battle the Neolithid.
Yeah, I was actually thinking like lime barricades that people can hide behind that maybe could survive 1 or 2 blasts of acid.
Okay. Yeah, I love it. So, guys, this coming Wednesday, you can see me play a Power Ranger in a delightful TTRPG. We're only on episode 3. You have like nothing to catch up on. And then the following Wednesday, I'll be DMing over on Cheshire Vic's channel for Guns, Magic, and Steel.
Where you can also see me.
Where you can also see Dapper, and you can see Chesh, and you can see Gusset Gibbon, and Bent. And
actually, I have a feeling she might not be there because I'm pretty sure her wedding is really close.
They're getting married. We got to figure something out. I got to chat with her because they can't not be there for when you guys fight the Neolithid again. Anyway, so yeah, if you want to see me do D&D stuff, that's over there. My channel will continue to update sporadically. I'll just let you guys know what I'm doing when, as well as I can. One more plug for Dapper. I'm going to go in and edit the description to link his channel here in just a second because I forgot to do that earlier. Yeah, anything you want to plug while I'm adding your channel?
I mean, I plug pretty much everything I've got. Like, please do come hang out for Kent with Bent. I get drunk. It's at the point now where Tuesday is one of the most weeks. The only time I even get close to being drunk is on Tuesday, and it's usually so stupid that I'm actually pretty hammered by the time it's time to stop the show and then go over to my Discord channel. Which, by the way, guys, I have a Discord server for patrons and channel members, where I do stuff like have watch parties after Kent with Bent, and just sometimes hang out and talk to people. It is the most reliable way for anyone who is a fan of the channel to get a hold of me is that, because I actually keep pretty close tabs on that server. I have a fan-made server that I keep much less close tabs on. For one thing, there's too many people for me to keep track of all of them. But two, I mean, if you're in the server that you had to pay for, you're basically paying me to pay attention to you. So I'm going to do it because you're my boss. To some extent.
To some extent. Smitty, you're absolutely correct. Kent Hogan did raise Dapper's alcohol tolerance.
Which is hard to do, given that I'm a former sailor.
Yeah. Okay. Well, again, thank you guys so much for joining us on this journey of nonsense. And I will see you so soon. Okay. Bye.
Bye.